The process of flooding is normally need-based, but in most of the networks, there is a need for periodic updating as well. So the flooding is carried out from time to time. We'd look at the situation which is necessitated by periodic flooding first, and then we'd look at the option of not sending out the periodic updates and flooding only when there's a need. In this module, first we'll convince ourselves about the redundancy of periodicity. We'd explore the need-based updates, the problem that was found earlier in periodic updates, and how non-periodic or aperiodic updates handles the situation by using a combination of sequence numbers and non-periodic updates. Gallagher and Bertzikus have included very interesting routing scenarios which highlight the algorithmic implications of these networks. And by looking at these, one can understand that flooding with periodic and non-periodic updates can be utilized to increase the overall consistency of the network. The redundancy of periodicity has to be understood first by understanding that why periodic updates are used. Periodic updates are needed because if some updates are sent whenever there is a link change, but because of node crashes or transmission errors, these updates are not incorporated. Or a node crashes and then recovers and comes back to the network and say it lost the time when the event was taking place, so it could not get an update. Now, when a periodic update is sent, it is going to keep track and it is going to become in sync with how others know the network topology. Under normal circumstances, this periodicity is not a strict requirement. We call that need-based updates. A special case arises when a node crashes. So when a node crashes, what happens to the sequence numbers that it currently had? What happens to all the updates which took place while the node was undergoing the crash and was recovering from the crash, not in fully stable state? Well, a zero sequence number is allowed when a node is recovering from a crash. So using a zero sequence number is dedicated to the usage for a crash recovering node. When a node is recovering from the crash, it brings up its all links. So say a router or a node is connected to 4 different networks, so it has 4 individual links. So when it was not on the network, 4 parts of the network considered it to be down. When it is back, it has to update the information and share the status between and for different parts of the network. So when a node recovers from a crash, it starts with a zero sequence number all the time. So does this solve the problem? It solves the problem only partially, because we shall see when a node recovers from a crash, it uses zero sequence number. What if 2 nodes crash and start recovering? This causes a problem. Let's explore the problem first. Here we see that nodes 1, 2, and 3 are connected in tandem. What if the link 2, 3 goes down, and after that link 1 to 2 goes down as well, and after a short while link 2 to 3 is restored? So when the link 2 to 3 is restored, node 2 resets its sequence number to 0 because it has just recovered from the crash. Node 2 and 3 exchange their information about the status of the link 1 to 2 and 2 to 1. It is interesting to note that both of these are going to use the sequence number 0. Now in that case, both of them are going to discard the updates sent from each other. because both of them carry the same sequence number. So the problem which arises is that the network updates are not incorporated in their memories. How do we figure out the solution? The solution is to use some kind of lexicographical or lexicon kind of rule. Lexicon rule means that A comes before B, B comes before C. So we can define some kind of precedence between the routing updates. Now, if you look at this situation, when 3 sends its update to 2, 3 has a higher sequence number, so 3 would take the precedence. And 2 will wait for a while, and then it is going to update 3 about the network state as well. What happens? Either the correct view of node 2 regarding link 1 to 2 is communicated to 3, or node 2 will wait for a while, it will issue a new update message with sequence number 1 because 3 takes the precedence, and its information or its updation would now be acceptable by 3, and the overall network state shall be known to all the nodes in the network.